Hey class, Mr. Moyden here with a video lesson here to help you understand how to use circuits from a Boolean expression to help you figure out the truth or falseness of a particular statement. So if you take a look at this example problem, you should have it on your handout. It's kind of hairy looking. You can see there's quite a bit of ands and ors and a's and b's and c's, three inputs. That makes things more complicated. So let's see if we can use some physical apparatuses to help us make sense of this problem. Our overall strategy is this. We're going to draw the circuit out on paper, and I'll remind you how to do that. You're going to start with the central operator, and then mark your inputs, and then sort of connect everything with the gates and the wires to sort of make sure that everything that's logically written is actually physically manifested. We're then going to use a website to build the circuit, and we're going to use a light bulb, again, digitally on the website, to represent 1 or 0. For the output. So if current is going through, if the result is true, then the light bulb will be on, and opposite for false. And thus we can use the combinations of switches on the digital circuit to figure out which combinations are true or false purely through the circuit and not having to tax our brain quite as much. So let's look at that statement again and see if we can draw the circuit. So I encourage you to follow along with me on your paper. If you look carefully with the parentheses, you basically have two halves. You have this half, and then you have this half. And they're bridged together with this OR symbol. So starting with that, I'm going to put my OR symbol here. That's going to feed my output. So in the last video I showed you, you can mark that as a variable. You could do that, although for our purposes it's actually going to be a light bulb. But for now, the current would continue in this direction. And there's two things feeding into it, the blue half and the red half. Don't quite know how long they're going to be at the moment, so I'm just going to sort of mark these arbitrarily. I'm going to start with the blue half because it's pretty simple looking. I have A, B, and C. Now the last step said on the previous slide to, at this point, mark your inputs. So let me do that. I'm going to put an A, a B, and a C. And those are going to be switches that have current either on or off depending on their position. So the first one here in blue is going to be an AND gate. I'll try to do this in colors. An AND gate. A and B are being ANDed together. So A is coming out and B is coming out, and they're being fed into an AND gate, which looks like this big D thing. And they're directly feeding into the OR gate that we had earlier. So these two together are coming right in here. Now notice A and B are actually, or B at least, is going to be showing up multiple times here, so we can't really say we're done with B. So this part of the problem looks to be done. Our next operator, looking in the red half of the problem, we do this in green, is this other AND. So this is bridging together this portion here, B or C, and this portion here, B and C. So putting that AND operator close to the end here would be this, and that's going to feed into the OR gate because that's the central symbol in this part of the expression. So this is going to have two inputs. One of them is, wish I had more colors handy. One of them is this part right here, B or C. B or C. So B and C have to be ORed together with this symbol right here. So I'm going to tap the B line and bridge it and make it meet up with C for the first time in an OR gate. And the result of that OR is half of our AND statement here, so that's going to feed right into there. However, B is also being ANDed with C, so this is going to be a little bit tricky. Let's see. I'm going to use lighter green here. B is ANDed together with C, so a little AND gate. B, I'm going to jump over this. Whoop. It's going to be joined up here, and C is also going to be tapped, and it'll feed into the very same AND gate. And the result of that AND gate is the other half of this dark green AND gate, so that's going to feed in right there. So if you look carefully, we've accounted for all of our inputs, A and B and C, in all the ways they sort of show up. You can see that the central operator here, the OR, is sort of the ending point, and then you have the two halves, blue and red, and then we broke it down further beyond that. Remember, the loops here are a way to indicate that we're not really intersecting, but just overlapping these wires. So now we have our circuit. There's going to be quite a few combinations of ones and zeros among these three. So with only two inputs that we've been doing so far, P and Q or what have you, there's been four possibilities, right? We've gotten used to by now doing 0, 0, 0, 1, 1, 0, and 1, 1. So when you have two possibilities, 0 and 1, and you have two inputs, P and Q, then you have 2 squared or 4 possibilities. But this time, since we have 1, 2, 3 inputs and still 2 possibilities per, that means we have 2 to the third power or 8 combinations of zeros and ones. And that's what the little table you have on your paper is showing. So we're going to build this circuit, and I'll show you at the end here how to actually do that. But I went ahead and built one already that represents this digitally so that we can actually play around with the combinations. So here's the logic table of all the 8 combinations of zeros and ones that are possible. And let me try to get this to, there we go. And you can see that I already built this circuit ahead of time, and like I said, I'll show you how I did that in just a bit. So the first result, the first row here is 0, 0, 0. So I'm going to treat this to be A, B, and C, sort of the logical way. And big surprise, if they're all off, then this will be off as well. Now, it wouldn't be a surprise if there was a NOT gate in there, but in this case, there aren't any. So the next one is 0, 0, 1, which means I'm going to turn on C. Let's see what happens to the light bulb. Nothing. So that's no good. B and C this time. Oh, hey, how about that? Interesting. You can kind of see the path of the power, which is one nice thing about this particular implementation. Just B. Oh. Just A. Okay. A and C. Good. A and B. How about that? And all three at the same time. Also good. So we're able to use the circuit to sort of do a lot of thinking for us, and here we have the truth table from this particular gate. Now, one thing that we'll learn in the future is how to write a Boolean expression from a truth table. That's going to involve something called the sum of products. That'll make more sense in the future. But for now, we're taking a Boolean expression, making a circuit, and using the circuit and its properties to create a truth table based on that particular expression. So let me show you in short how that was actually going to be, how you make one of these things. So you're going to log on to this website, and this will be on this board in just a moment, logic.ly/demo. I think I already have a window of it open here. Okay, so when you type that in, you get here. So what you're going to do is you're going to drag a light bulb over first. That's your output. And I believe all the problems I've made for you have 3 inputs. So those are going to be our toggle switches. So you just drag and drop. Looking at some of the other tools here, they're pretty self-explanatory. This is the undo key. This is the redo key. And if you want to delete something, you can, normally, when you click it, it'll bring up this little stop sign. You can click that to delete something if you do it by accident. So let me just briefly show you what it would look like if you connected some things together. Let's say I want to put an AND gate, and then later on a NOT gate, and maybe an OR. Maybe an OR somewhere in there too. I can just click and drag the nodes to feed into various gates. And if I need to tap a line, so what we did earlier on paper was to actually just draw a dot here, you can just use the same output of the toggle switch to feed into multiple things. Now in this case I haven't done a very good job because I have nothing to connect my C here to, but in any case, let's see, just playing around with this. Right now it has power, which you notice is peculiar, but not when you realize there's a NOT gate in there. So if I turn that on, huh. Well, that's the danger of just playing around with things. Sometimes you end up with circuits that are constantly running, and you get electrocuted here. Anyhow, you get the idea. You can play around with these to build physical manifestations of what you draw on paper. So the next part is for you to play around with these circuits and expressions and create the circuit and then evaluate the truth statements. All right.